Just before, as we talked about just before going on the break, June's going to take us through some blueprints, which is very exciting. So I'm going to remove myself and take it away, June.
Thank you very much. All right, so after 5.5 hours, we are finally going to write some code that is going to make things visible to blueprints because, as is probably not a surprise, but your designers don't want to work in C++ and your artists definitely don't want to work in C++. So we are now going to write some stuff that is going to allow us to expose all of the native code that we've written to blueprints. Now, you can obviously create base classes in C++, like we've got this game mode base here in C++, and we can create base classes for actors and components and all sorts of things. But what I want to talk about is blueprint function libraries, asynchronous latent blueprint nodes, and then also subsystems. Excuse me. So we might start with subsystems because they're a nice thing to build some functionality off. If we go into C++ classes inside our test project, we can go and create a new C++ class. And if we go into all classes, we can now go and create some subsystems. There's going to be a bunch of junk here that we don't care about. Don't want that. Okay, so the ones we actually care about is like game instance subsystem, local player subsystem, and world subsystem. And these are basically, they are things that are like, so if you make a world subsystem, right, and this subsystem exists for every world, right, as a new subsystem for every world. Make a game instance subsystem, it's a subsystem that's available throughout the life of the game. And all of these subsystems can be accessed through blueprints. So if you make a local player subsystem, for example, you can access this subsystem that you make in C++ off the local player. So it's a great way of sort of like encapsulating functionality that needs to be tied to the lifetime of like the world or the player or the game. So I'm just going to make a game instance subsystem. We can make this real quick. And then this is going to be like, hey, do you want to like stop debugging because the project's got regenerated, which is totally normal. I'm just going to let Unreal Engine do its thing. Cool, yeah. We're going to reload all, and yes, we are going to stop debugging because Unreal Engine will try and like rebuild our code and hot reload. We don't care. We're just launching. I've just been launching Unreal Engine from Visual Studio. So obviously, if you're going to do that and you're going to hit, do you want to stop debugging? Yes. It'll make sure that you had saved everything in the editor before we click yes, because it's just going to kill the editor. But we now have our game instance subsystem. And the really basic blueprints that you might already be familiar with is blueprint callable. So if we go void my blueprint, then we go over here and we're just going to make ourselves blueprint. You know what? I'm just going to put a breakpoint on it, and so we can see it in action. I'm going to run Unreal Engine again. And so these are like the blueprint. This is like the blueprint node stuff that you might be familiar with, just adding a new function onto a C++ class. Very straightforward. There's not much to these. So I won't dwell on them too much. I did say I was going to talk about blueprint function libraries, actually. I will make a blueprint function library, though my recommendation these days is like subsystems are where it's at. The advantage of function libraries over subsystems is blueprint function libraries don't need an instance, right? Whereas like if you're calling something off a game instance subsystem, you need to get the subsystem from, you need to get the subsystem when you're calling the function on a subsystem. So I'll do the blueprint function libraries in a moment, but we will just go into our content. We need to make a new actor. So make a new character, test actor. Right, now we're running the editor in the Visual Studio debugger, which means this debug point, this breakpoint here is live. So we go and don't open on that screen. I want our test actor. Cool. Begin play. So like I want to have. So someone in chat is asking, will you be showing how to add a new subsystem source collection? So like if I want to have subsystems spawn from an actor or something. So subsystems are defined at the C++ level. So whatever you define, I'll show you in a moment. It's going to make a lot of sense. If I get my game instance substance, see, it's just like this global function, right? It's just this global function that gets you the instant subsystem, because there's exactly one of these, right? So you wouldn't really use these at, like, you can't dynamically create new instances of the subsystems because their lifetime is tied to, you know, the world or the player or the game instance. If you wanted to have functionality that was tied to like the lifetime of the actor and you wanted to dynamically instantiate it, what I would do instead is actually make a C++ component, and I would attach that component to the actor, because then you could, you know, if I add a sphere, whatever, you can then have functions off your, you know, C++ component, and then the lifetime of that component would be tied to the actor. Hopefully that makes sense. Someone asks in chat, the U function blueprint callable, is that like a decorator in C#? It kind of looks like a C++ macro, though. Not too sure what's going on there. Yes, so remember before how we were talking about the generated body magic? This is more generated body magic. It's not magic, it's just macros, but hang on a second. So if we look at generated body, no, it's not generated body. Sorry, we want to click on this generated.h. Now we've got this my blueprint function. If I go over to here, we can see my blueprint. I can. It's a function that the editor is aware of. And if we search for my blueprint in this generated header file, we will see whether we get a bunch of like helper functions. You know, these are functions for like, I think those are functions for networking. If we, this is the header file. If we go and look at the gen.cpp file, we will see a bunch of helper functions for a bunch more helper functions, I should say, for the blueprint functions, as well as, excuse me, all the metadata for the blueprint functions. And then this is basically like the properties, right? You've got like this function info. It links to the function or to the thing that constructed information about the function. So I think if we look up here, we will see probably, we don't have any parameters for this function, but I would expect all of the parameters would like get thrown into the metadata here somewhere. And then, yeah, it expands out here. You can see the function info gets passed into the class parameters. And then it passes through all those global constructors like we talked about before. And that's how the editor and the runtime knows when we're calling my blueprint that it's going to propagate all the way through to the address of this function here when we call it from blueprints. Hopefully that answers that question. So if we're going to begin play, we're going to just tie this up just to demonstrate it. Save that. I'm going to save this map, test map. I'm going to quickly set test map as the... Wow, that's fancy. I haven't seen that before. Cool. I'm going to set this map as the default map, so we just don't have to keep switching between it constantly. And then I'm going to put test actor in a world. Oh my lord, this is absolutely massive. This is huge. Unreal, this is unnecessary. I don't know how to get close to it. Whatever. We hit play, and guess what? We hit the breakpoint. So now we have a blueprint function on our game instance subsystem. We call it, it gets hit, it gets run. And you can put whatever you want in here because you're dealing with like, you know, native C++ code. You can, you know, obviously use all of the C++ APIs, but you can press F to focus on the actor. Oh no, I clicked on the wrong thing, test actor. Oh, fantastic, excellent, cool. It's all the way here. So yeah, so you can do anything. You can call like native libraries, you can call third-party libraries, you can do pretty much whatever you want because you've got the full power of C++. So this is really simple blueprint functionality. Let's do something a little more complicated. I'm going to just close the editor for now. Yep, save that. So that's all well and good for like blueprint functions that are just going to instantly return values. But what about things like network calls? Like not game networking, but like let's say we want to hit like a HTTPS API, and that's going to take some time for... Why is this visible now? I don't know what's going on there. Yeah. So we're going to, so we're going to call like a HTTP API. It's going to take some time to respond. And we want, from our blueprints, we don't want our blueprints to have to like deal with polling or anything like that. We just want to call a blueprint node and sort of, continue our logic when it comes back. So blueprints has this thing called latent blueprint nodes, or I like to think of them as asynchronous blueprint nodes. And so the way these work are slightly different because there's no async await in C++, right? Like you can't just do like, async whatever, like you would in C#. So we don't define a latent blueprint node this way. What we actually do is we make a class for it. And so this class is going to look like this. So we might, and I'm looking at code that I've previously written as a reference for this because there's quite a few building blocks that we need to put together. So to make this latent blueprint node, let's just call it my blueprint node. I'm going to get u blueprint async action base, which is the base class that we use for blueprint nodes that are asynchronous. That is going to need a include. So I'm just going to include the required header for that. As usual, we're going to have our generated body, which is going to do our uObject macros and other insertions that we're going to get. We need to have a callback pin. So this is going to define the outputs for this blueprint node. So I'm going to declare a dynamic because we're doing output prints, multicast, delegate, and then however many. What about blueprint functions that can auto-convert the return type? For example, get active class. If we get time, I will talk about those. We might investigate them, we might not. I'll see how we go for time. Just remind me at the end of the session once I've covered all my dot points, and we'll hopefully have a look. So the parameters that you're defining here is going to be the number of return values out of the asynchronous blueprint node. If you just want one return value, then you would just use one parameter. If you want like two parameters, like say we're doing a HTTP request, we want the status code and the body, we might do two parameters, right? And then we're going to call it my blueprint node return delegate. You can call it whatever you want. Someone in the chat says wildcard inputs too. I suspect it's wicked complicated though. It is wicked complicated. So I will show you existing code that does it. I'm not going to try and write it in the session because it's fairly complicated. So we want two parameters. Let's just give the first one. We'll make the status code, and we might have HTTP body. I'm not actually going to implement HTTP calls yet. We might do that in a later session. But we're going to make our thing, our return delegate type, and then we're going to do on result. We can call it whatever we want. We'll see how this propagates into the editor in a moment once we make this. We now want to make a u function. This is blueprint callable. And we're going to set this flag saying blueprint internal use only true. And the reason for this is, oopsies, I need to actually do my function header static u print node. And this is going to be called my blueprint call that is async. We're going to make this call off the game instance subsystem. So we're actually going to take the game instance subsystem as an input. You don't have to do this, right? Like if actually, you know what? I'm going to keep it simple, straightforward. We're just going to pass no parameters in. You can pass in whatever parameters you want, right? So like if I wanted to have an async blueprint node that comes off this subsystem, I could take the first parameter as a subsystem, right? And then what I would do is in the private fields of this blueprint node, I would store this, right? So I actually want to do this, right? And then when I implement this, I would like keep track, this should be property. I would keep track of the subsystem. And then when I do the activate function, virtual void activate override, and this is when the blueprint node is actually going to get executed, I could then use the subsystem. But you could do this for any parameter. You can take in anything. Actually, I might take in like a, I'm going to take in an int, test int. In test int. Now you'll notice that IntelliSense is still complaining about all of this stuff, and that's just because we haven't actually built anything yet. And of course, because we haven't built any stuff, all of this is expanding out to macros that don't have like, expands to line 21 generated body. Well, there isn't a line 21 generated body yet because we haven't done a build. So that's why this is all still complaining at me. Let me go get my reference code real quick. Okay, excellent. So over here, we've got two functions we need to implement. We've got my blueprint call that is async, and we've got activate. So my blueprint call that is async, we go here. This is going to return a new instance of the blueprint node. So this is like a factory. All right, it's going to take in the int test int. So yeah, good point. What does question is, what does blueprint internal use only function do behind the scenes? What this is doing is basically saying that when you're in blueprints, you're not going to be calling my blueprint call as async off a my blueprint node. This is just going to appear as a global blueprint function you can just use in the graph. So this is basically hiding this function away and saying like, don't surface it to the don't surface it in like autocomplete or anything like that, because this part is actually internal. The blueprint system, or the editor blueprint system, will already surface the entire node as a blueprint node. So we don't want to see this like subcall inside. Hopefully, yeah, it's just kind of basically hiding it away because this is an internal, an internal thing. So we've got our factory function that is going to create a new instance of the blueprint node. And this is how, if you think about when we're making the call, every time we call the blueprint node, and because it's an asynchronous blueprint node, we're going to give each call its own set of state, right? So then every single time we go into this blueprint node and in the graph, it's going to construct a new copy of this node. So we're going to go node, new object. So there's our same new object that we're talking about before. We can set up our parameters. So in this case, we want to set our test int to be the test int that we passed in. And then we're just going to return the node. And we have now created a new instance of the blueprint node. And when we call, now we need to implement activate. This is what's actually going to be called when the node executes. Activate. And then for the node to finish, what we will do is we will go and call the on result. Now, again, IntelliSense is going to complain because we haven't built yet. It's a multicast, a dynamic multicast delegate, so we're going to broadcast it. I don't think we gave this a parameter. Oh, we did. We gave it a status code. So I'm just going to do that, and let's just pass in empty, nothing. That should be this. Now, obviously, if you're looking at this and you're saying, well, this isn't really asynchronous. We're not doing any asynchronous work. We'll make it asynchronous just to kind of demonstrate how this all fits together. I think that's it, but let me just double check and make sure there's no no cleanup to do. It's because it's garbage collected. So what is going on here? Why is this not sized properly? Windows, please, I'm giving a talk. I don't need you to be weird. Windows being weird. Okay, blueprint callable, sorry. Okay. Hey, so now it's built successfully, and then after a moment, IntelliSense will be happy about all of these generated body stuff. So let's run the editor. Whoa, fancy. Test actor, let's focus on that. Edit test actor. But guess what? It's going to open a new... Oh, no, it didn't open a new window. Interesting. So we've made our async node, and if I've done this correctly, we should be able to search for my blueprint call that is async, right? So remember, this name, the name of this here came from this function name here, the internal name, not the class name. it's coming from this here. Even though that we did flag this as internal use only, the editor knows that a blueprint async action base should be treated like this. It should be this Latin thing. So we can go in and we're going to pass in, I don't know, let's say 5. And then when we get our result, now you notice there's two exit pins here. This is after the Latin call has been started, but you've called activate, but it hasn't necessarily finished yet. And this is our delegate callback that we defined as a property here. Now, all properties, if you're going to have as many, you can have as many return, or you can have as many exit. So I have multiple delegate. I can have multiple output execution pins. That's what I want to say. So I could have on success, on failure. The only thing that's actually important is that all of the pins have the same delegate type. So if you want to have on error and on success, they all have to have the same return delegate, because you can't vary the parameters by what type of output pin you've got. All the output pins here are the same. So all of the output pins you define for all the different callbacks you might have just have to share the same delegate signature. If we go print string, and let's do this, so I'm just gonna. The HTTP body is just going to be an empty thing, so we're not going to do anything useful there. Get activate details. Cool. Event dispatcher is not blueprint assignable. Thanks. So I need to go fix that up. Save selected. This should be blueprint assignable, I believe. Because internally, the blueprint system needs to assign a handler to this delegate. If I check my reference code that I was looking at, I believe that will be the case. It should be. Yes, it's just blueprint assignable. That's all I was missing. Wouldn't it be a problem to you property with int? Shouldn't it be int32 for it to be properly serialized? Apparently not. I'm pretty sure that if you just use int here, it's just going to get aliased, because int by default is int32. Like int32 is int and int32 are both 32 bits. If you want to do a 64-bit, it's long or int64. So int is fine. If you just want 32 bits, it's fine. Look, I mean, technically, yeah, for conventional correctness, I should be using int32, but since this is test code, I've just put int. But you are correct. It should be int32 to be specific. All right, let's go back to our test actor. Let's try and compile it now. Cool. It compiles now. Great. If we run a game, you will see immediately we see 5 printed out. That wasn't a very long print. Let me go make that take a little bit longer so we can see it a bit longer. So we begin play, it calls the blueprint node, and because we aren't doing actually any asynchronous work, it just immediately prints 5. It immediately returns. But let's make it do some asynchronous work so that we can get a feel for what this looks like. So what I'm going to do is I'm just going to use, remember before when we set up some tickers? Well, I'm just going to use the core ticker. Probably a better way of doing tickers, considering we're already inside the object system, but again, this is sort of just to illustrate the advantage of using Latin blueprint nodes. I'm not going to bother taking the delegate handle because we will effectively unregister the thing when we will unregister the delegate when we return false to say please don't tick this anymore. So I'll go and make a handle. Yeah, that's all I need. Chuck this up here. Oh no, sorry, it needs to be bool and it needs to have float delta time, because that is the signature for tickers. Bool. Return false because we only want this to tick once. And then we're going to broadcast. We're going to call our event. And then we are going to just make it say take 10 seconds for this ticker to fire. And we will now run it. And now what we should see is that when we call this blueprint, this Latin blueprint node, it will take 10 seconds before we get that result pin firing. right. Let's jump into the... Oh, we didn't really open the test actor, but I will anyway. If we run it now, we will see it starts. Hey, nothing's happening because we're running that ticker. And then after 10 seconds, we should see, fingers crossed, 5 appears. Yeah. So we can see 5 appears up in the top left corner after 10 seconds because the result pin has now fired. So you can imagine that you can replace this activate with like a HTTP call or any other sort of asynchronous work that isn't like instant. And then we can basically have asynchronous work that, from the perspective of blueprints, just flows normally. Something that's really important to note is that with these asynchronous blueprint nodes, you can only use them in the event graph, right? So like I can't, if I make a function here, I can't call the async blueprint node because all the functions in blueprints are synchronous, right? You can't access them here. If you wanted to do that, you would have to basically have, add custom event, do async thing, and then from your function, you could be like, do async thing, right? And then that would go off and do the asynchronous work. This would return immediately, but then do async thing could like wait for the event and do all that. Wait for the async code to finish running. Hopefully that makes sense. Someone asked, do you have to restart Unreal every time you compile and run? So I'm sure someone will correct me, but when you are adding new classes, like because I've added a new class here and I've added new functions, I do restart the editor. If I just want to do, like, say I want to make this 20, right? I'm not changing any function signature at this point. I'm not adding new classes. I can hit Control Alt F11 for live coding to basically hot patch all the C++ code. And whoops. Oh God, what's going on? Go by the way, I don't need that. So now live coding has patched in the new changes. And now if I run it, we will see that it takes 20 seconds. It'll take 20 seconds to respond. Someone in the chat says, I think live coding can't handle header changes. And yeah, that's correct, because if you think when we're talking about all of that Unreal header tool stuff where it's generating all of the metadata for classes and properties and functions, and how all of that gets loaded into the system through the global constructors of like static data, those global constructors, yes, we can see 5 has just now appeared. All of that is not going to happen again when you do live reload. So, live reload. So that's why you can't like add functions and add classes in live compile. You need to basically quit the editor, redo or make your function or class changes, and then launch the editor again. And so someone says, so every time you edit a header file, you have to restart the editor. The answer is yes, you do, if you want to be doing like C++ stuff. At least I do. That's the flow I do every day. It sounds daunting. It's not that bad, but I don't know. Your mileage may vary. I'm sure people have many strategies to optimize that flow. What was I doing? It was what was the next point? Sorry, I got a bit distracted there. Okay, cool. So we've covered blueprint nodes. We've covered asynchronous blueprint nodes. We've covered a little bit of subsystems as well. I will show you really quickly what it looks like if I pass in the subsystem as the first pointer, as the first parameter to this async node. So if I go like subsystem, I won't actually use it, but I just want to emphasize what it looks like. Because normally you would take the subsystem parameter here, and then you would store it as a U property on the blueprint node, and then you could access all the data that you're storing inside the subsystem. You could access it from here, and because you don't have to surface that those fields to blueprints, you could have global game instance data that's accessible to C++, and you can only access it through the blueprint nodes that you've surfaced which kind of makes it harder for like designers and artists to accidentally like break systems that you don't want them to have access to the internals in. Yep. Let's edit test actor. So now it's going to say I need the subsystem. If I go get the game instance subsystem, my game instance subsystem, I can drag up and go my blueprint call and see how it's like. Now it looks like an async function off the game instance. I'll just wire it up. And so that can give you, that's how you can sort of like put async functions on not just the game, not just these subsystems, but you can put them on actors, you can put them on anything, right? Because you can take any U object as like parameters here. And so if as long as it's a U object parameter and you've got a U object value in the blueprint graph, you can just sort of drag off and search for the function, and Unreal will basically provide that as an autocomplete option for you. Blueprint function libraries, I'll cover them real quick. I'm just going to make one in the editor. And then you can see the difference between a blueprint function library and a like a subsystem. All right, let's go C++, test project, and let's go new, and we're going to go all classes, and we're going to go blueprint function library. I think that's what it's called. Yep. Next, my blueprint function library. It's going to make our stuff. It's going to try and build it. Visual Studio will say, do you want to reload? Yeah, we do. Do you want to stop debugging? Yes, we do. That's fine. Oh, come on. Come on, give me the thing. Okay, cool. Now, to do blueprint functions in blueprint function libraries, give me one moment. Yeah, cool. So in this case, because we don't have an instance, all of our functions are going to be static. So if I do function blueprint callable, static f string hello world, I won't take any parameters, it'll be fine. Oh, I do need to implement it though. Otherwise, the linker will complain at me, as will be a common theme. Okay, there we go. Now, when this hopefully builds and runs, we can see what this looks like in comparison to like a game instance subsystem. Oh, it must return a value. Of course it must. Right. So let's just open up our test actor and have a look at this. So now we can just call hello world wherever we want. It's just a global static function. It's not off anything. Yeah, I just remembered another thing I could talk about. So it's just a global static function. Doesn't take anything in. Just gives you a return value. Looks pretty statically global, like nothing particular going on there. However, if you think about it, right, I mean, from a C++ perspective, this is not particularly that useful because you probably want to access like the current world, at least. You want to access some game systems, right? And you can't really do that with this function signature because it's static. Because it's static, it doesn't have access to anything that's in the, it doesn't have access to any context through the blueprint function library. It doesn't have access to really anything. So there is a parameter that you can ask for called a world context object. And what this allows you to do is to get to access the world information in C++ without actually having to specifically pass in a without having to specifically pass in an object as a parameter here. So we can use meta. We can say our world context parameter is called world context object. And we will see what this looks like. I need to go here, add that. And so if we wanted to actually, we would use this, and to get the world, we would do get world, right, just off the world context object, and then we can, do stuff with world, like look up players and actors and that sort of thing. But let's have a look at what world context object looks like in the editor when we've added it. Would this be a good time to ask about the auto convert the return type? You mean how I'm just returning text hello world here and it's actually an F string? Because F string has an implicit cast defined on it. So you can convert it. F string defines an implicit cast where it's like, hey, I can be implicitly created from any tchar pointer. So it means any time where the compiler has a tchar pointer and it needs to have an F string, it'll like be like, okay, cool, I can just implicitly cast that. You don't need to cast it. The auto convert the return time. I will talk about that in a moment. Yes, I will. I will come back to that question. So now we look at hello world. Wow, it still doesn't have a parameter on it, and yet we can actually access the world context here. We can access the world, we can access actors without having to actually pass in an object here. And it's because the hello world is being called from inside a U object that has a world. So actors are in the world, you can therefore call hello world without having to specify a world context object, and it's all happy, it all works, and it just implicitly flows through. If you try and use the hello world blueprint node in the context of something that doesn't have a world, I kind of suspect that UMG widgets would fall in this category, as well as some like really low level U object classes. Then you will see a world object context parameter appearing here, and you'll have to pass one in so that this function can operate and know what the world is. Someone in chat is asking me, how does things like get actors of class work? I'm really hoping that this works, because I hope that I can double click on this and it will actually take me to the C++ symbols. If not, I will find it for you. The idea is that you have a, like if you get an audio volume, then the out actors is an array of audio volume object references, right? I would like the definition of this class, please. Definition of this function. Yeah, so pro tip, double clicking on blueprint nodes is a great way to find out like what they are actually made of. There's some nodes that are more complicated than you can cover it with just like sticking metadata on things. So let me have a look at this. I'm just going to word wrap this real quick. Word wrap. So I haven't looked at this particular example. I was kind of expecting this would be what's called a K2 node, which is stands for Kismet node, which is like the internal code word for blueprints. So if you see Kismet anywhere, it means blueprints. Can you please word wrap? Thank you. Okay, so it looks like for get all actors of class, there's just metadata that you can stick on it saying, hey, this array of actors is actually dynamically set to the type of actors that are returned is defined by this subclass parameter, and that's what allows it to cast. There are more complex examples of blueprint nodes that require a bit more to them than just that. Just trying to think of one off the top of my head that would qualify. I have an example in my own code that I can actually go and use to find what the proper base class is for looking this stuff up. So just bear with me for 1 second. Go find it. Oh, did I put it? Oh yeah, here we go. Public. So UK2 node. So K, it means, well, K2 is like Kismet. U is because it's a U object. Okay, so if you want to do really advanced stuff in blueprints, like blueprint nodes that can have like dynamic outputs, dynamic inputs, that can do really pretty much anything to do with blueprint graphs, you can inherit from the class UK2 node. You'll need to do this in like an editor or a developer module, and I'll be talking about modules later. You can see that this class has a bunch of overrides for things like allocating default pins and like, you know, getting the menu actions so that you can right click on the blueprint node and get stuff out. So you want to go like really fancy, you can use UK2 node as like the base class and just do whatever you want. And then, you know, like if I do, where is it? Expand node, I think is what we're looking for. Yeah, expand node. Okay, that looks really simple, but trust me, that probably goes into a whole bunch of code from those function calls. It can be very complicated to do the stuff. But you know, if it's worth it for your project, if it saves your designers and artists a bunch of time because they can just use a blueprint node that, you know, has the behavior that's going to match for your game, then it's probably worth it. So I'm not going to go into it. This API surface is absolutely huge, and I probably couldn't cover this in an entire day, let alone a few minutes. So yes, I think that's pretty much it for writing blueprint nodes.